Welcome. Thanks for coming to the talk. I'm here to talk about MCollective, an introduction, if you will. I kind of wanted to ask and see who here knows what MCollective is. I'll try to shield my eyes from these bright lights. So a lot of people know what it is. OK. Who's actually used it before? Fewer, but still a decent number. OK. Has anyone here written any custom agents or plugins for MCollective? OK, a couple. So this is kind of introductory. It is an intro. So if you're looking for like more details on how to write agents and whatnot, I won't really be getting into those details. But you're welcome to stick around, and maybe you'll have some good questions for me, or something later. Anyway, so I'll go ahead and get started here. Orchestration. So that's one part of what I think MCollective is used for. So often it's used for ad hoc reporting on systems, or triage against lots of systems, or orchestration then. And so orchestration I think of as just the coordinated management of actions across lots of nodes, or just more than one node. So in the realm of orchestration, I kind of have a picture of an orchestra, because that actually relates pretty well. In an orchestra, you've got musicians that have their notes that are already written that they're going to be playing. You got this coordinator or conductor kind of coordinating everything. And that really relates well to systems, I think, because your systems, your nodes are basically the individual musicians, I think of. They have these actions that they're going to do, these predefined notes. And then there's someone coordinating and conducting all the actions across your systems. So I'm going to kind of relate MCollective to this orchestra thing throughout this talk. If you only have one system, because your application maybe doesn't require multiple systems, you don't necessarily need orchestration. Your configuration management tool will pretty much help you out there, because they tend to be node-centric. So you have yourself a one-man band. You don't really need to worry about orchestrating and making lots of music with lots of people. So a little bit of history about me. I've been a Unix sysadmin for over 10 years. I actually got my start working on AIX systems. It was rough, but it was all right. So what I'd worked on originally was automating the management of like 400 or so AIX systems. And to do that, we kind of wrote this in-house configuration management system of sorts, where we basically write this shell code. We could test it and validate it, and then push it out through our remote execution tool. And it would kind of roll through all the different systems and deploy the stuff. And I kind of bring this up because working with that as my introduction to Unix really kind of, I think, framed the way that I wanted to manage systems and how I looked at managing systems from there on, where it's really nice to be able to have some code that you can test and validate before you actually push it out to all your systems. And we weren't actually manually updating all these systems, which, back in early 2000 or so, this was, really cool stuff for us to be doing, I think. But today, things like Puppet and MCollective make it so much better, because they're not nearly as rough as the tools I was using. They're actually quite pleasant to use. And now I don't have to write everything from scratch. Like, they're nice. So on to the meat, if you will, of talking about MCollective. All my examples here are going to be with MCollective. I don't know if they'll translate to other orchestration tools. They might, but probably not. So to get started, MCollective, some basics on it. It uses a client-server model of sorts. It's definitely not the one that you might be familiar with, where you got a bunch of clients that all connect to a single server. With MCollective, it's different. You have a server. A server is basically just your node running an MCollective daemon. So all of your servers are MCollective servers. MCollective also uses middleware, just some like pub/sub middleware, where all your servers connect to it and subscribe to different topics. This is in contrast to a lot of other systems that might use SSH, and I'll definitely talk a little bit more about that later. So at this point, we have all these servers connecting into this middleware, and nothing happens, because they're just sitting there listening. And that's where the client comes in. So the client is basically a program that lets you connect to the middleware and send messages to all those servers to tell them to do something, and then wait for a response, and then show you the response. And so the whole picture ends up looking something like this, where You got your client who's going to send a message out to this middleware. Middleware is going to distribute it to all your servers. They're going to pick it up. They're going to act on it. Send the reply back to the client who's going to show you on your interface what actually happened. So conceptually, that's kind of how MCollective works. That's kind of the transport. And so I think it's kind of important to note that MCollective really is just this platform, this transport kind of platform view. More than anything, it's a framework that lets you have this base layer. And to actually use it, you have to add stuff on top of it. MCollective is very pluggable, and so you add plugins on top to actually do stuff with it. There's 4 plugins that I'll mention here. Agent plugins, which actually do the actions that you want to have occur on your nodes. Security systems plugins, which give you all sorts of authorization, authentication, auditing, all those kind of like security things that you might want or need. There's connector plugins, so you can use different sorts of middleware. And there's data plugins, which can give you more interesting ways to identify and filter your nodes. So agents. They're the main thing that you're going to be using MCollective for. They're the things that are actually doing stuff on your nodes. When you want to do anything, you're going to be doing it through an agent. So I'm actually going to cover a few of the common ones here. The first one being the package agent. So the MCollective package agent actually leverages the Puppet package type. So you have all the same platform support in MCollective that you have for packages within Puppet, which is kind of nice. And without further ado, I will hope that my demo works out, that you can see it. Can everyone see fine? OK, so let's do this. All right, So we've got this command line here. MCO is the primary tool or interface that you're going to be using to interact with MCollective. I'm passing it the name of the application that I want to invoke with it, which is package. And then I'm telling it, here's the package name. And finally, the action I want to run on this package is the status. So let's see if we have rsync. We do have rsync on all 4 of the nodes I have here. So we can also do other actions, such as uninstalling this package. And it's prompting me here for operating on all the nodes. I think, yes, that's fine. I don't want rsync because it's dangerous or something. So now it tells me what it did. I can look at the status again and see that it's absent. So just kind of going over the output here, there's this progress bar, which shows you what nodes or how many nodes it's operating on. And it goes through this discovery process and then does your action. And then it reports on a node per node basis here what it actually did or what it shows for those nodes. And then you have some summary information below. That is basically it with the package. I could install this package, but I don't trust the network to actually function for me, so I'm not going to show you installing a package. But you can imagine that it just installs a package. So moving on, there's a service agent. And similar to the package agent, it's leveraging the Puppet service type. So you have all the same platform support that you have within Puppet, which, again, is awesome. Something important to note with this, though, is, again, MCollective is not using SSH as a transport. So we can do something like stop SSH. So I need to have the service. So similar to the package, it's MCO, the application is service. The service is SSH, and I'm asking for the status. And it says it's running on all our nodes. Let's stop it. And we can look again, and there is no SSH running on these nodes anymore. But we still have full control of them. So we'll go ahead and start it back up. All right. And we have SSH running. So again, important to note, this does not use SSH, which is useful in many ways. Not that you really want to stop SSH, but you know. The next agent I'll talk about is the Puppet agent. So The MCollective Puppet agent lets you manage the actual Puppet agent on a node. It lets you do things like run Puppet on your nodes with options like no ops or tag or environment. It's pretty flexible with how it'll let you run Puppet. You can even run it against all your nodes with a specific concurrency, and so it'll help you roll out Puppet runs consistently across all your nodes. It'll let you report on Puppet runs and statuses, and it'll let you manage Puppet resources with the Puppet RAL, which is pretty interesting. And so some examples with this agent here. So we're using the Puppet application. We're giving the run all action, and we're going to say 3 is our consistency. So this is going to run Puppet across all the nodes, 3 at a time. Once one of them finishes running Puppet, it'll start running on the next. So it goes through its process of finding which nodes to run on, knows it needs to run on 4. It has now kicked off Puppet on 3 separate nodes here, middleware 1 and 0. And as soon as one of these completes, it should then kick off Puppet on the final node and then exit. And hopefully it doesn't take forever. But it might. So I'll give it a couple more seconds before moving on. All right, I think that's long enough. So again, networking might be causing me problems here, but we can just move on. So the next thing we can do is look at the status of Puppet on these nodes. So we can see 3 of them are actually applying a catalog, probably because they can't actually access the internet, so they're hanging on various actions, and there will be timeouts that occur at some point. So this is useful to see what state your nodes are doing, what state of Puppet is on all your nodes. We can also get briefer information with count. It just shows high-level information about it. This application also has this summary report, which gives these nice sparkline graphs. So when we're using this Puppet application, we're not actually using or invoking the Puppet agent directly. We're using this application, which is some front-end code that talks to all the Puppet agents themselves. There's another MCollective application called RPC, which lets you interface directly and get raw results back from agents. So as an example, we'll use RPC. We'll look at this last run summary. So the Puppet agent itself has an action called last run summary, whereas the application has just summary. So we'll look at this data, and we see we have a lot of other data, not those fancy sparklines. So the application that does just the simple summary that shows those nice graphs, it's just parsing all this agent data to build those graphs themselves. And so this is where the front-end code ends up being separated a bit from the agent so that you can do more with it and make it more presentable, where the agent can just be kind of raw and send data. In addition, this also supports JFlag, where all your output will just be JSON. And this makes it really easy to parse and integrate with other systems or scripts or anything like that, which is a kind of nice feature. Let's see. I think there's a little bit more I want to show on this. Yeah, introducing one other agent here. There's a file manager agent. And it lets you look at files and see if they're there. And in this case, this file is not there. So I want to create it using the Puppet RAL. So let me give that a shot here. So here, we're running the Puppet application again, using the resource action. And then the information about this resource is basically like a Puppet resource declaration, where we say the file is this, and the content is that. And actually, let's match what I was doing earlier. So I go to run this, and it rejects me. It doesn't let me actually manage that resource with Puppet. And that's because there's some safety built in with this agent. By default, it doesn't allow you to manage Puppet resources. If it did, then you could do a lot more stuff with it. What we'll go ahead and do here is enable this on one of our nodes. So we're setting this configuration parameter for this plugin. We're going to blacklist exec, which is automatically going to whitelist every other Puppet resource. We'll restart our agent here. And now, when we run that resource command, we should be able to create the file on just the one node where we enabled it. And we're able to. We can look at the file. It's indeed there with our content. If we go back to the file manager, we can see that that file is indeed present here. And final thing we can do with file manager is remove a file. It failed on those 3 nodes. It wasn't there, but it should have worked on ours, and now it's not present anywhere. And so that's kind of the gist of the Puppet agent. So I think with MCollective, it's pretty important to understand that, or it's a good practice to not just be shipping shellcode and running like Puppet execs with it, because MCollective runs pretty fast. The middleware that it uses allows it to send these messages to all the nodes at the same time if you want. And so it's a lot faster than SSH. If you're running through 200 nodes, telling them to do something, and you're doing it via like some SSH for loop, you can always Control-C or break out of it and limit your damage. With MCollective, if you were to do something like that, the Control-C typically isn't going to do any good because all the nodes have already received the message and they've already done their action, and it's too late, and everything has been affected. So MCollective definitely allows you to shoot yourself in the foot pretty easy. It's fast, so you break things fast. And those checks and balances are there for a reason, to give you the input validation and testing and like verification that the action that you want to run is going to do what you want it to do. So kind of relating it back to the orchestra example, these agents are basically the sheet music that the musicians are going to be looking at and using to do their to play their piece. Next thing I'll talk about are filters. Get some water first. So when you run MCollective commands, like I was before, without any filtering, it just runs across all the nodes in your environment. And more than likely, that's not what you want, because that's not always the most useful or proper thing to do. Filtering lets you really kind of narrow the scope of what you're going to be running commands and actions against. And there's a number of different ways you can filter. There's collectives and identity and facts and yada, yada, yada. And I'll kind of go over a few examples here. The first example being collectives. So collectives aren't strictly filtering. They're more of like a logical grouping kind of thing. But they're definitely the most basic way to group your nodes with MCollective. By default, there's a single collective called MCollective, but it's a parameter in a configuration file that's just like comma separated. So you can add as many different collectives and subcollectives and whatnot that you want to. And based on what's in the file, it will determine what collectives your nodes are a member of. And so then this allows you to target those specific collectives to run different actions on them. And to kind of relate this to the middleware, each of these collectives ends up being, so each agent actually has a separate topic in the middleware, and each collective for each agent has a separate topic as well. So this really kind of helps you isolate where you're sending your commands using collectives. As an example of some sub-collective stuff, we in the past have used some collectives kind of like this, where we had a single global collective that every single node was a member of. Then we'd have some geographic specific collectives. And then inside of there, we'd have more functional specific collectives, so that we could target groups of nodes in more specific ways. And so when we'd send commands to our particular component of nodes in the US, it would only talk to those nodes. We wouldn't have to worry about the middleware shipping the data over the sea and whatnot and back. So it allowed us to really focus on a specific subset of nodes. And it's pretty useful. I had no examples of using collectives because my demo here only has a single collective, and I'm just not going to bother showing that. So identity filtering is another way to filter your nodes. That is just simply filtering your nodes based on their host name or FQDN, basically whatever you configure the MCollective identity for on your node. As an example, we can look at what our identities are here. So if we just use this ping, it's going to go out and run a simple ping of sorts against all the nodes. It returns back the identities of these nodes. So we can actually target these nodes specifically using this -i flag. So we can ping just that node, and we got it. In addition, identity can just be a simple regular expression. You don't have to fully qualify everything. So we can do something like this and get just those two nodes that match that. And that's basically all there is to the identity filtering. It's pretty useful, especially if you have very rigid host naming standards and whatnot. In addition to identity, we can filter with facts that are provided via factor. MCollective can either execute the factor program on its own, or it can look into like a facts.yaml, and I'll touch on that a little bit more later. But as a quick example, let's look at some stuff here. I assume that everyone's familiar with factor and what factor is. If not, it's basically a simple key value store with info about your node. So we're going to use this inventory, which is a nice application within MCollective that lets you get a bunch of details about a different MCollective agent. So let's look at the inventory on this node. Lots of stuff here. First section just shows some basic agent-related stuff, or MCollective daemon-related stuff. It tells you which agents are available on that system, yada, yada, extra stuff. And then finally, we come down to the facts. And so we see all the facts that are available on this node. And we can filter these nodes based on facts. So let's go ahead and show a quick example of that. We'll use find, which just finds nodes simply. We'll filter with facts. And the fact that we're going to look for will be IP address ETH1. And again, these can be regular expressions as well. And we should see whatever nodes match those. And we do. So uses just any random fact with any kind of regular expression, and it's a very useful way to find things. So talking more about using that facts.yaml versus just executing factor on its own. Using like a YAML file for your facts can actually have some benefit if you're writing this via Puppet, because you can add into that file any Puppet variables that you want to have present on your node as facts as well. So if you have an ENC of sorts that is adding extra variables that your systems or that your Puppet modules are using, you can actually get those presented as facts via MCollective by writing them out into this kind of facts.yaml. And there's some great examples on the MCollective documentation site on how to actually create these files. But I definitely recommend using it. The next kind of filters are your configuration management classes. It doesn't matter what system you're using. MCollective actually supports Chef as well. But the configuration management classes are basically whatever's listed in your classes.txt file. You point MCollective at the classes file, and then it will use those as filtering points. So if we go back to our inventory on our node, we can see configuration management classes here. This one has a number of classes. It's got the node role. So let's find nodes that have this role. And it's as simple as just saying this class. We have 3 nodes. That's cool. And that's it. Next one are the data plugins, which I think are really the most interesting and kind of the most powerful ways to filter. Looking at the inventory again, if we go back up, we see we have a number of different data plugins available. Data plugins have a lot more interesting ways to filter. I'll kind of show a quick example to illustrate that, but let's see. Let's find nodes that have a process running, and we'll look for Redis server because we're using Redis as our middleware in this little demonstration here. The syntax, I think, is totally not straightforward, but you're probably not going to be writing all this stuff on a command line. Hopefully you have it wrapped in some sort of application or script or something that you're using. But I need to use the correct syntax to actually get it to do what I want. You need a minus on the S. So this should find any nodes that only have that process running. And this middleware, this node that we're on, should have that process because he found it. And sure enough, he is running that process. So based on processes, based on services, based on a number of other things, the documentation for those data plugins shows a lot of different examples and a lot of additional things you can get out of it, but definitely a useful thing to use. And that's data. So using filters are basically letting you identify this section of the orchestra that you want to do something, locating the players, if you will. So we can actually tie all this stuff together. And so I have a simple example here of what someone might want or need to do. So let's find all nodes, or actually let's look at the status of a service on our node roles. I need to say the action. So we see we have SSH running on all these. Let's go ahead and stop SSH on a couple of them. And it's only acting on the two that I identified there. And so we look and we see it's running on one, stopped on two. Well, let's go ahead and start SSH back up again. But let's only affect the nodes that are not running it. So let's not even do anything with the node that's already running it. So we can add another filter on a service data plugin. So in this case, we're going to say, let's start SSH on these nodes that match this class, and only start SSH on the nodes that aren't running SSH. So this should only affect 2 servers, not all 3. And indeed it did. So when we go back and look now, we should see that SSH is running again on all of our servers. And that's kind of tying all the pieces together and kind of showing what you can do with it. And this is like the conductor telling one section, hey, you play your stuff. But that's definitely not a full orchestra. That's not orchestration completely, I think. It is close, though. An example of actual orchestration or full orchestration, the way I think of it, would be like doing a rolling restart of your application across multiple servers. You could probably do something like, service nginx restart and hit enter, and what's going to happen is it's going to restart on all your nodes at the same time, and your site's probably going to go down, and it's not going to be good. MCollective has batch modes, so you can run against batches of servers. So you could say, hey, batch one at a time, sleep for 5 seconds between this restart, hit enter, and it's going to restart in the rolling kind of fashion. But what happens if you end up pushing out a bad config, and the restart fails, and your application doesn't come back up? It's just going to slowly take down all your nodes, and at the end of it, your nodes aren't going to be running. So orchestration, I think, needs to take that into account. The way you do that is with some additional code on top of just these actions and whatnot. A super simple example of how you might be able to do this would just be writing some bash code. This example, it's basically finding a list of nodes that we actually want to operate on. Once it has that list of nodes, it's going to go through and it's going to restart our service on one node. It's going to wait until it's running again, and if it is running, then it's going to continue on to the next. In this case, if it fails to come up on one of the nodes, it's just going to stop right there, and you're only going to have one node that isn't actually running it. If you're interested, I can actually show you that, I think. Indeed. So we can run that. It's going to restart. It's going to wait and move on, and so forth. And so this is, kind of the orchestration that you should actually be going for. In addition to bash, you could write it in Ruby. So it's probably really hard to read, plus it kind of cuts it off at the bottom. But it basically does the same thing, just with a little bit better logic, so it doesn't sleep as long. We can run that as well. MCollective, or with with this Ruby example, you can actually import MCollective and use RPC functions within your Ruby code, so you can actually integrate it more fully than calling out to some like shell command, which can be useful if you use Ruby. And that's kind of it for my examples. I think orchestration hopefully moves beyond just performing actions on these groups of nodes into this whole like code that needs to take into account how your systems actually run. These examples, you could easily add in more logic for other layers of nodes. Like if you have web apps and DBs and whatnot, you could put enough code in there to actually take into account everything to gracefully deal with all your systems. And that's kind of what I had to talk about with orchestration. Kind of related to it, I can talk a little bit about Jive and how we use MCollective. We're not doing too much orchestration with it. For us, it's primarily an ad hoc kind of tool. We have 15,000 nodes or so, and they're in various geographies and data centers and whatnot. And MCollective is great at being an ad hoc tool to say, hey, what nodes are susceptible to this vulnerability because they have a specific version of a package or because their uptime is a certain amount of days. And so MCollective is great for just asking infrastructure questions in general. It's also great for triage and troubleshooting. We have an mgrep agent that we use, which is basically grep from MCollective. So we can query thousands of nodes at a time, looking for a string in a file, and get instant results. And that's super powerful when you're trying to troubleshoot inconsistencies. We also do some periodic data collection, getting information about nodes that maybe we'll stuff into a database or something like that for auditing purposes. Doing mass actions across all the nodes, like actually destructive commands, always makes me kind of nervous, because if that filter is wrong, the potential of affecting a lot of things that you don't want to affect is kind of great. So ideally, we would be executing our MCollective actions through another tool, something that kind of abstracts and gets you out of the way, the business of crafting these careful command lines that are hundreds of characters long. So ideally, we'd have like a text menu interface or a simple web interface or something. I believe Puppet Enterprise gives you a nice web interface to kind of piece together your commands. We're not using Enterprise, so everything we do ends up being kind of crafted based off of what our need is for the day. Yeah, I think that's, for the most part, what I got to say. This demo is possible because of this MCollective Vagrant, and it's very nice. I want to thank Ari for this and everything else that he's contributed. But yeah, definitely check out this Vagrant thing if you haven't used MCollective before. It's easy to get set up. It'll spin up this environment that has lots of nodes. You can set in your Vagrant file whether you want 3 nodes or 20 nodes, and you can spin up as many as you want to play with it just to get the feel for it. And that's all I have. If there's any questions, raise your hand and I'll try to find you. Okay, you. You have one Redis instance for all 15,000 nodes? So the question is, do we have one Redis instance for all 15,000 nodes? No, definitely not. We don't use Redis. And I think Redis really shouldn't be used for anything other than a demo purpose, because it has no security at all. We use ActiveMQ. We actually have 20-some ActiveMQ brokers that are clustered. Each data center, each silo, each whatever has its own redundant pair of MQ brokers. And then we link them all together using just ActiveMQ clustering technologies. Yeah?
Some slides back, you had a layout of different zones you had. So you had US and EU, and then within US, you had US something, US something, US something. And I was wondering if there was a reason you didn't just strip the region name from within the region. Would you not be able to check against the region tag and the role?
Okay. So the question was about the collectives that we're using. So I think this is the slide, right? So the question is there a reason we're being specific about US services versus EU services? If we were to just say services, then it's going to be services that bridge both US and EU. These collectives are global, so we could definitely, and actually that's kind of, I think the better place to move towards would be using US services and just services, so that if we wanted to see all services nodes, regardless of what geography they're in, we could talk to them. Whereas in this, we would have to do one query to US services, one query to EU services to actually talk to all of them. But yeah, just what the collectives themselves aren't actually containerized like this. It's just kind of a logical picture showing what it would be like. They're just simple strings, so if you put just services, then all the nodes would be in just services. Does that kind of answer it?
Would you not be able to run a query for things which are US and services, or can you not?
Okay, so the question is, would you not be able to run a query for things that are US and EU? And the answer is no, you can't. You can only pass one targeted collective to your MCollective command. All right. Yeah?
Yeah, I was wondering, what's the process of configuring nodes to talk to a particular MCollective master or whatever it's called? Like, is it a matter of setting up like a Puppet, you set up like this is the master hosting?
Okay. So the question is, how do you configure MCollective to kind of talk to the master or something? So in MCollective, there is no master. You just configure your nodes to talk to the middleware. And a client is basically just another piece of software that talks to the middleware as well. The client is like this MCO command, for instance. But the way that you configure your nodes to talk to the middleware is just through the config file. I can show you that here. So under here, we see we're going to connect using Redis. The Redis host is that, and that is all the configuration you need to connect to Redis and actually talk to Redis. If you're using ActiveMQ, or if you're using SSL, if you're using passwords and whatnot, you have additional properties that you fill into the files here for connecting to those kind of things. Does that kind of answer it?
Yeah.
Cool. Yes?
Does that mean that any client can issue MCO commands?
Does this mean that any client can issue MCO commands? Clients can, yes. This is a server. So typically, you don't install an MCollective client on all your nodes. You have dedicated nodes that you're going to install your client on. And if you do install the client on all your nodes, then yes, all your nodes could run MCollective commands and talk to all your nodes. But typically, you restrict the nodes that can actually run this. You'd use maybe SSL certificate authorization so that you have users tied to certificates, and only certain users can do certain things. There's other plugins that allow you to restrict what plugins a user can actually execute. So you could say, yeah, user Joe can only access or can only run the package agent, or actually he can only run status on the package agent or stuff like that. So you can definitely get pretty granular with how you lock down access. But in general, you have your certain client nodes that you set aside for actually doing the commands and actions from. All right. Yeah?
You mentioned a couple of middlewares. Are there any that are better at scaling?
I think the two primary middlewares that anyone uses are ActiveMQ and RabbitMQ. I haven't had any experience scaling RabbitMQ. I believe others have, and they've taken it to thousands of nodes. We're having pretty decent time now with ActiveMQ, getting it scaled up to deal with our nodes. So yeah, if you have familiarity with one or the other, definitely pick the one that you like best or that you know best. But yeah, I think either of those two would work. And I think those are the primary ones that anyone would use. Anyone else?
Yeah, right here. Are you actually using MCollective to kick off Puppet runs? Now you got it completely set up, or still have it?
OK. The question is, are we using MCollective to trigger our Puppet runs? Not right now. For certain classes of nodes, we probably never would. We have another orchestration tool in-house kind of thing that we use to trigger Puppet runs. A lot of other nodes we just run in daemon mode. I think as we move more to some sort of like continuous integration, continuous delivery kind of thing, I think MCollective is definitely going to play a part in triggering Puppet runs. Or at least in my vision of how we would do that, it definitely has a part there. But it's not something we're using yet.
Do you use it, is it mostly you just using it kind of interactively, or use MCollective scripts?
Yeah, so the question is it something that we just use interactively, or do we have scripts and whatnot? So primarily, it is ad hoc. Like, we don't have a whole lot of automated processes using MCollective right now. There's definitely a lot of places where it would benefit us. We just haven't dedicated any time to actually building out these things. So right now, our usage of MCollective is, ad hoc reporting, triage kind of things. Like if we have major issues on a bunch of nodes, it's an easy way to help triage for the most part. So yeah, it's mostly just an ad hoc tool for us right now.
Yeah, another question along those lines. You have some kind of urgency. I know, like you were saying earlier, you don't want to use it to run some kind of ad hoc shell script. How do you handle that in an emergency situation?
Yeah, so I guess the question is, with the kind of fearfulness of running actions across tons of nodes, I did mention triage issues where we actually would use MCollective. So basically, it's just be careful, don't mess up. If we have, a number of nodes that have some serious problems, then yeah, we definitely want to do what we can to get them up. And so maybe we'll create like a node list of the nodes that we want to affect, and then pass MCollective that node list file for which nodes to operate against. I didn't show that in any of these demos, but rather than using an identity filter or something like that, you can pass it a file with a list of hosts that you want to talk to as well.
How do nodes get into a collection? Is it merely the ones who connected to the middleware, or is it like pre-configured in a config file with all your nodes on it?
Okay, so the question is, how do nodes get into MCollective? Is it maintained in a list somewhere, or is it just something else? And so the answer is it is something else. So any node that connects to this middleware, that's configured to connect to the middleware, will become part of MCollective. When I was running these commands, it was actually going through a discovery process where it looks at the middleware and sees what nodes are connected, and then it will send the command to execute the agent to them. So it does like dynamic discovery of who's available. So if you have nodes that come up and go down and come up and go down, it will just dynamically discover them as needed. If you have like a more rigid list of nodes that you want to maintain, you can use a different kind of discovery filter where maybe you have a database or something that tracks your nodes. So instead of doing this broadcast discovery across the network, it just discovers based off of your list. And I think when you use that file-based like targeting of nodes, I think it skips the discovery step because it already knows the list of nodes to actually target.
When you set up MCollective, I saw that there's a Puppet Labs MCollective module, there's an ActiveMQ Puppet Labs MCollective module, an ActiveMQ Puppet Labs module. Besides those two modules, is there anything else that you do to get everything set up?
So the question is, there are ActiveMQ Puppet Labs modules for Puppet and MCollective module as well. And is there anything beyond just using those modules that you need to get set up? I think these days those modules are probably enough. They have enough configuration knobs and buttons to actually do anything within MCollective. And I think those are definitely the way to go. The documentation on the Puppet Labs website is pretty great. And I think there's a MCollective book as well now that's available that has a lot of good information on how to do this.
And I have coupons for people who want 50% off the book.
Awesome, coupons for 50% off on the book. Save one for me. Any other questions?
When you mentioned the dynamic discovery, I noticed that in your slides you had specified collectives already. If you're doing dynamic discovery, are those specified collectives based on some configuration file, or are those just based on, like, for example, the roles class or something like that?
So the question was around the dynamic discovery and the collectives. Let's see if I can show a little bit of info on this. So this config file has collectives defined and then main collective. So the client configuration file as well has main collective. And so when you run it without listing any collectives, it'll automatically target that specific collective. So it's always only going to talk to the nodes that are a member of that collective. It doesn't talk to anything outside of that. So like in our example with that picture that I was showing, like the main collective would be global. So by default, you're going to talk to everybody.
And the other collectives are specified in the same file?
The other collectives would be like in this list of collectives here. I would just have one, comma, the next, comma, the next, comma, the next. And when I want to talk to the other ones, I would just target them specifically.
Do you create those collectives by node name or?
So it's just a simple string. Like if I wanted to create a new collective, I would just put in a name of a new collective, restart the process, and then it would connect to different topics on the middleware broker, and they would instantly become available.
And the topics are created by agents?
Yeah, the topics get created by the MCollective agent. So when they start, they'll connect to the middleware. And the middleware needs to be configured so that the agent can actually write to these or create these topics and whatnot. And so like with ActiveMQ, we have these funky ActiveMQ authorization strings that say whoever the server user is able to create things named this or that or whatever. So yeah, if you wanted it, like in this Redis example, there's no need for any of that because Redis is just wide open here and lets anyone connect and create anything that needs to. All right, I think I'm out of time here. Thank you.